So our next presentation is going to be hunting backdoors in Active Directory with Thermu and Anurag, both from Mandiant. So excited to see this. You know, when I was looking over the presentation earlier this week, I was, you kind of as an investigator sometimes think, I've been in this industry for so long, I feel like I have a good handle on everything out there, but I was really amazed looking at this presentation on how much I took away from it and how much I learned just by looking at the slides. So I'm really excited to hear them talk about this, about Active Directory, something that is such a large part of, the environments out there and such a large attack surface, and the way that attackers can utilize this for persistent mechanisms, privilege escalation. I think this is going to be a great talk. So with that, I will turn it over to both of you.
Hi, everyone. Thanks for joining this session, Hunting Backdoors in Active Directory Environment. My name is Thiru. I am a principal consultant in Mandiant, predominantly supporting customers to respond and remediate to major security breaches, and also to assess the security posture of their Active Directory and cloud environment. In today's session, we have a lot of hunting context to discuss around threat actors, techniques, and tactics observed in Active Directory environment. I'm going to take a pause for a while, and I'm going to let my co-speaker Anurag to introduce himself to start with some content. So before that, let me check the slides, but I can move my slides. Yeah.
Thanks, Thiru. Hi, everyone. My name is Anurag. I'm a manager with the CrowdStrike services team here in Singapore, where I do incident response, working with customers when they are tackling breaches, when they are battling adversaries, when there is ongoing threat actor activity in the environment. And I'm also a SANS community instructor. And today, we will talk about hunting backdoors in Active Directory. If you can move to the next slide. Yep. This is a threat hunting talk. This is a threat hunting summit. And threat hunting is the process of looking for threat actor activity which traditional detection mechanisms fail to detect. And every hunt starts with a hypothesis. And that's what we're going to do. We'll take a hypothesis and then we'll run through a process and come to a place where we either confirm the hypothesis which we have, reject the hypothesis we have, or come to a conclusion that we do not have enough evidence to either confirm or reject that hypothesis. And that's exactly what we're going to do today. We will put out hypotheses regarding backdoors in Active Directory environment. And then we will talk through the process of how defenders can hunt for these hypotheses and confirm or reject this hypothesis. At the end of the talk, we would like everyone to walk away from here with a better understanding of how threat actors are putting these backdoors in Active Directory environment, and to be able to take these techniques back and to be able to hunt for them in their environment. But why have an entire talk on Active Directory? Active Directory is the bedrock of identity for over 90% of Fortune 500 companies. It's the underlying fabric of infrastructure that supports applications and services in a lot of organizations. And once a threat actor has that privileged access in Active Directory, they can own and move around in the environment at will. A lot of times we do eradication events where we try to remove threat actors' access in the environment. And that's where we see the threat actors using these backdoors. They keep these covert and hidden paths that they can use when they need to get back in the environment and regain that privileged access if they ever lose it. Active Directory is a very lucrative target. And we as threat hunters, defenders, security professionals, we cannot afford to surrender that fort to the adversary. We need to know how we can hunt for these threat actor techniques in the environment. But one thing I would like to warn you here, this talk is fast-paced. We have a lot of slides, we have a lot of hypotheses which we want to share with the community, share with all of you. And the deck has a lot of codes and snapshots, and we may not be even able to talk through most of them. The idea here is to provide enough information for everyone to take it away back in their organization and to be able to use this to hunt across the environment for the backdoors which we're going to talk about. So please stay close with us while we'll take you to this whirlwind tour of backdoors in Active Directory, and we show you how deep this rabbit hole goes. I'm going to hand this over back to Thiru for him to talk through the first hypothesis.
Thanks, Anurag. So let's move to the first hypothesis. A threat actor have already compromised Active Directory server, and they have created backdoors in order to maintain a persistent privilege access over it by abusing Active Directory permissions over a user account that they control. And this is the hypothesis. There are various permissions that exist in Active Directory servers, and this can be assigned to security principals to perform specific actions. DS replication is one among them. Security principals carrying this DS replication permission can extract the password hash remotely from Active Directory servers using directory replication servers remote protocol. So this permissions can be assigned by domain administrator's privilege. Threat actors can abuse this permission by assigning this right to one of the compromised user account they control. There are various tools to change these permissions. So one among them is PowerView. So after this setting, threat actors at will can leverage the permission of the compromised user account in order to retrieve the password hash of the targeted user account, which can be a KRBTGT account, or it can be a domain administrator account. So this technique or this attack is called as DC sync attack. We can detect this technique by monitoring Active Directory server logs. The event ID 4662 will be generated for any changes that happen to the directory services object. This includes addition or modification of the DS object. We can also do a proactive hunt by listing out all the DACLs configured in the DS object and then filter out the DS replication permission GUID. So through this approach, we can identify security principals carrying DS replication permission over DS object. Senders is also another permission type. Security principals carrying senders permissions over other user accounts. So the security principals can send email as the other user without any evidences recorded in the other user mailbox. So this permission can be assigned in Active Directory server, and this can also be assigned through Exchange Admin Center or Exchange Management Shell. Exchange administrators, along with the domain administrators, have privileges to assign this permission to a different user account. So threat actors can abuse this permission in order to send email as a targeted executive in a covert manner. So we can hunt this technique by monitoring Exchange server logs if in case this permission is assigned through Exchange Management Center or Exchange Shell. So the event ID 1 will be triggered for any commandlets execution in Exchange servers. So we can narrow down the hunt by looking for commandlets like add-AD permission with extended rights as senders. And you can also leverage PowerShell commandlets to list out all the user objects and the associated DACLs. Then you can narrow down the search specific to senders permissions delegated to a specific or other user accounts. So through this approach, we can identify all the security principals who's carrying senders permissions over other user accounts. So these are some of the commonly targeted Active Directory permissions. So threat actors with these permissions, they can perform different activities like resetting the password of the targeted user account without knowing the current one. They can set a script path for the targeted user so that whenever a user logs into a system, the scripts defined in the path gets executed. They can also register service principal name for the targeted user account so that later they can brute force the TGS ticket in order to derive the password hash. So do a periodical hunting, understand and identify security principles carrying these permissions over the critical organization units, where the privileged accounts are the critical servers like Active Directory or ADFS servers are parked in. So these are some of the valuable AD attributes that threat actors can target. MS-MCS-ADM-PWD. So this specific attribute carry the clear text password details of local admin accounts when the local admin accounts are managed through labs utility. So threat actors can create backdoors by maintaining a read-only permission over this specific attribute for the targeted computer accounts. So do a periodical hunting by listing out the security principals who maintain permission over this specific attribute or the targeted computer object. MSDS-key credential link. So this attribute carry keying material of the user accounts or computer accounts. So this specific attribute is used when an organization is using PKI to support Kerberos pre-authentication using X.509 certificate, or when an organization is using Windows Hello for Business Services to support second factor authentication. So threat actors can abuse this attribute by generating their own private public key pass and then write the public data into this attribute for the targeted user account or a computer account, which can be a domain controller too. So later at will, threat actors can request and receive the Kerberos ticket for the targeted computer account, which is a domain controller. So here, even if an user account or the computer account's passwords are changed, still threat actors can request and receive Kerberos TGT. All right, so they can get the ticket for the targeted account, which can be domain controller, as I said. So this act as a shadow credentials set by threat actors for the targeted objects. So do a periodical hunting, understand and identify AD objects carrying value in this specific attribute. There may be situations where your organization may not be using PKI or your organization may not be using the business, Microsoft Windows Hello for Business Services. Following that, MSDS- allowed to act on behalf of other identity. So this attribute is configured when resource-based consent delegation is set. Through RBCD, a computer can define who can it trust and who can delegate authentications on them. Threat actors can abuse this specific attribute by using one of the compromised SPN, service principal name, and they can write it over this attribute on the targeted domain controller. So that later at will, they can log into the domain controller as a domain admin or a server administrator. Leverage PowerShell commandlets, identify AD objects carrying value in the specific attribute. Okay, let's move to the next hypothesis. Threat actors have already compromised Active Directory servers, and they've also compromised ADFS servers, and they have created backdoors in order to maintain access over ADFS token signing certificate. This is the hypothesis. Active Directory Federation Service, ADFS. So this is a Microsoft single sign-on solution. It enables federated identity and access management in order to share digital identity beyond and across the organization security boundary. ADFS acts as an authentication proxy between the on-premises Active Directory server and the target application. Here, the application plays the service provider role, whereas the ADFS plays the identity provider role. This slide depicts the authentication flow when an ADFS is involved. I'm going to explain the flow in detail. An external user wants to access an application which has established a federated trust with the ADFS server. So now all the authentication will be forwarded to the ADFS sign-in page. ADFS will collect the credentials and will validate the credentials with the on-premises Active Directory server. So after successful validation, ADFS will issue a SAML token. You can consider this SAML token as a ticket that can be used by the external user in order to access applications. So this SAML token is signed by the private component of the token signing certificate by ADFS. Once SAML tokens are received by the service provider, so it will validate the authenticity and integrity of the SAML token using the public component of token signing certificate. So this information is exchanged during the federation trust process. So based on successful validation, now service provider will allow the external user in order to access the application. So this is how the authentication works when an ADFS is involved. So threat actors, after compromising the ADFS, they can steal token signing certificate. And with that, they can create forged SAML token, which is signed by the compromised token signing certificate, and they can forward the token directly to the service provider in order to access the application. So now the authentication request is not forwarded to ADFS, which is in on-premises, and there'll be no visibility in the on-premises. So this attack is called as golden SAML attack, and it's very hard to detect this specific attack technique. So where is this token signing certificate located? So this is located in an encrypted format along with the configuration files of ADFS locally in ADFS in a database called Windows Internal Database, WID. And this can also be stored externally in a SQL instance. The decryption key is stored as secret in the DKIM container in Active Directory server. So DKIM stands for Distributed Key Manager. So ADFS service, every time it will retrieve the secret from the container and then will use it to decrypt token signing certificate in order to sign the SAML. The token signing certificate is considered as a bedrock of security in ADFS server, as stated by Microsoft. So who can access this information? The authorization policy in the ADFS configuration settings define which security principal can access the configuration files where the token signing certificate resides. So by default, ADFS service account, the local administrator account have access over it. And the DACL permissions defined in the DKIM container in Active Directory server will specify which security principal have access over it. So by default, ADFS service account and some of the privileged domain accounts like domain administrators have access over the container in order to retrieve the secret. So threat actors, after compromising the ADFS server and Active Directory servers, they can create backdoors in order to maintain access over the token signing certificate. As a first step, they will tweak or change the authorization policy in the ADFS configuration setting so that they can use one of the compromised user account to have access over the configuration file, or they can change it to allow all or any domain users to access the configuration file. So this can be achieved using various tools, and one among them is AD internals. And later they can change the DACL permission of DKIM container for one of the compromised user account. So with this backdoor, now threat actor can retrieve the token signing certificate and they can decrypt it, even if an organization is revoking the old token signing certificate and generating a new one. So they maintain access over token signing certificate. So ADFS configuration files along with certificates are stored locally in scenarios when Windows Internal Database is used, right? WID. So these files are also reachable through network to support ADFS replication process. In order to synchronize the ADFS configuration files between the primary and secondary ADFS servers. So threat actors can abuse this specific replication process so that they can use any domain joined machine to remotely retrieve the token signing certificate from ADFS server. So this is a new attack surface because threat actors don't need to log into the ADFS server locally. So the next step will be like they will retrieve the secret key, then they can use it to decrypt the token signing certificate and use it in order to create a forged SAML token, which is a golden SAML token. The key takeaway here is threat actor doesn't need to log into the ADFS server. They don't want to execute codes locally in ADFS server in order to retrieve the token signing certificate. So we can hunt and identify this backdoor by doing a periodical review over the authorization policy defined in the ADFS configuration file. Right? And if you observe a value is set to true without any SIDs, user SIDs defined in it, or if you observe a user group SIDs like domain users SIDs, then it means that everyone have access over the specific configuration file. And this is not a default setting. Someone has changed it. Then also do a periodical review over the DACL permissions defined in DKIM container and identify which security principal have permissions over it. And if you identify a standard user account having permissions over the DKIM container, this can be a misconfiguration or a threat actor have created a backdoor. So we have few more hunting hypotheses. I would like to turn it back to my co-speaker Anurag to continue the talk.
Thanks, Siru. I'll just try to get the control. So this hypothesis is about AdminSDHolder object. The threat actor is creating persistence using AdminSDHolder object. Active Directory defines certain accounts and groups as protected. These are typically high privilege account groups like the domain administrator and the enterprise administrator. And in order to prevent tampering for these groups, ACL template, access control list template is defined. This template is applied to the AdminSDHolder object. Every 60 minutes, a process runs, security descriptor propagator process. It picks up this ACL and applies this ACL to all the privileged accounts, the protected accounts and groups in the environment. A threat actor can change this ACL, the default template ACL, and add themselves to provide themselves access to the privileged accounts and groups. So on the left, a threat actor can add themselves in the ACL, providing them full rights over the ACL. And then when after 60 minutes, that SD prop executes, it will pick up this specific DACL now, this template, and add this DACL to all the privileged accounts, protected accounts and groups in the environment, essentially providing the threat actor access over these privileged accounts. In order to hunt for this activity, we can review the directory service access event ID 4662 if directory service access logging is enabled. And the other way to do this is to use PowerShell and look at the default DACL template, which is applied on the AdminSDHolder object. So if we see any accounts that are added which should not be there, that should trigger an IR. So that's AdminSDHolder. The next hypothesis is about cloud. So let's talk about cloud and let's talk about Azure Active Directory. Azure Active Directory is the Microsoft's IDP for the cloud, the identity provider for cloud. Azure AD can be used in itself to provide cloud identity, but what we see in most of the organizations is it is used in a hybrid configuration where it is configured to work with the on-prem Active Directory. And in most of these hybrid AD implementations, it is configured in a way which is known as pass-through authentication, or the PTA. In this specific configuration, there's a user. When the user tries to log into the service provider, the application, a lot of times that's M365, the user is redirected to Azure AD. The user types in their username and password. And then there is a AAD Connect server in on-prem, which is running a PTA agent. Now this PTA agent picks up those user credentials from Azure AD and runs them through the Active Directory. That's how the validation is happening. So if the credentials are correct, the user logs in. If they are not correct, the user is not allowed to log in. So which makes this specific server here with the PTA agent very critical. And that's what the threat actors can go after. So a threat actor can target this AAD Connect server and inject a malicious DLL into the Azure AD Connect authentication agent service. This is a service that is responsible for doing that authentication. Now, attacker can do that, a threat actor can do that using AAD internals. AAD internal has a module called PTA spy. That's a DLL which can be injected into this specific process. And once that is done, any authentication that is happening through the AAD Connect server, those credentials are logged in a text file on the AAD Connect server. Not only that, if the attacker uses the AAD internals PTA spy DLL, the authentication validation doesn't happen on the Active Directory. A user is just accepted as a successful login. So not only this can be used for credential harvesting, it can be also used as a backdoor in the environment. Now hunting this is where we start looking at that Azure AD Connect authentication agent service. So any suspicious DLLs injected in that, they need to be looked at. Another way to hunt for this is when this authentication happens, there are logs that are generated in Azure AD in the cloud, as well as logs are generated in on-prem Active Directory. When PTA spy has been put in, the backdoor has been put in, there will be no logs that will be generated in on-prem AD. So if we can compare these both logs, we can detect PTA spy or this specific technique if a threat actor is using that. Takes me to my next hypothesis, which is about using machine account password hashes. And this one is very interesting. As I stated in the beginning, we do a lot of eradication events. And one key aspect of eradication events is to perform an enterprise-wide password reset. And one piece in the puzzle which organizations often fail to reset during these events are machine account passwords. Machine accounts are a bit of an enigma. A lot of defenders do not focus much on those. But these accounts are automatically rotated by Active Directory every 30 days. And this 30 days is configured in the registry of the endpoint for which the account is getting rotated. If a threat actor can get access to this machine, admin access, they can go and change this specific registry setting. when they change this registry setting, and if they have stolen the hash of the machine dollar account, they can use that hash, create silver ticket, and access this machine. So here, in order to hunt for this, we can look at the registry value and see if it is more than 30 days. So in order to hunt for this specific backdoor, if we as defenders can look for this registry setting here, which if is more, the password age is changed, if it is more than 30 days, that tells us that someone has tampered with this specific registry entry. That's the backdoor which the threat actor can put in. Now, the next topic, the last hypothesis, is about group policy objects. And this is a little longer one. I'll try to go through this quicker. Group policy objects are used by defenders and system administrators in order to manage a lot of systems which are part of Active Directory. Threat actors can use these GPOs in order to access systems, in order to exert control over a large number of systems that are in the environment. Now, in order to do that, the threat actor needs to have capabilities to edit these GPOs. So that's the backdoor here. A threat actor can add a normal user account and provide that account delegation rights into the group policy object which they would like to change. So here, this threat actor has added themselves in the group policy, which is the default domain policy for the entire domain. Now, if a threat actor can do that, they can edit this, and then they can manage, or this is akin to threat actor having full control over the domain objects on which this group policy is applied. In order for us to hunt this, we can look for the GPO permissions and look who has delegation rights over these group policy objects. Now, that's not the only way how threat actors can grant themselves rights to change this or edit these group policy objects. They can also change DACLs for the sysvol folder. The sysvol folder is the folder where the group policy objects reside. If a threat actor can add a normal user account and provide that account rights over the sysvol folder, now the threat actor can directly go and modify those group policy objects which reside in the sysvol folder. They can do that with the sysvol folder, and they can also do that with the policies permission folder inside the sysvol folder. Both of these will end up threat actor having capabilities to edit the group policy objects. So what can threat actor do once they have this GPO edit rights? They can do multiple things. They can push malware across the organization. In this example, we are looking at a threat actor who is pushing ransomware across the organization because they got GPO edit rights. This is a very common technique used by ransomware threat actors. They can set up malicious schedule tasks. They can set up startup and shutdown script. So they can run mimikatz and do stuff like that. Another thing they can do is unharden systems. So essentially, they are enabling the landman hash, wdigest, cred managers. All of these are weak Windows authentication mechanisms. If an attacker can do this, they will end up either getting weak hashes, which they can crack, or getting clear text credentials in some of the cases. So this helps them maintain that access in the environment. They can also add privileged permissions. So one way to do that is create a restricted group, add an account they control, and add other users to that. And that's how they can get privileged access. And the other way to do that is to add specific rights. Here is the debug program rights, which is a highly privileged right. They can add remote desktop services, backup files and directories, log on locally, and all those kind of rights to themselves. In order for us to hunt for these GPOs, defenders can take a dump of this, export it using PowerShell or the GUI, and then review this for all these malicious entries which the threat actors put. Also, when these GPOs are edited, links are created, or the GPOs are created, there are logs that are generated. So EID, event ID 5136, 5137, those are some things which we can monitor to see if an attacker is creating new group policy objects or modifying or linking group policy objects. Now, while creating this presentation, we looked at a lot of work which is being done by a lot of security researchers. So these are some of the Twitter handles which you may want to follow. And these are our details. So we'll hang around in the Slack channel. There's LinkedIn and Twitter details. Please feel free to reach out to us if you have any questions, any comments, or any feedback. Thank you very much, everyone, for your time. And back to you, Mary.
Oh, thank you so much, Dero and Anurag. I have to say, there are some presentations where I start watching them and I start to get scared, right? Like, oh my goodness, look at what can happen. A lot of the comments I saw in your channel going on were talking about ways, are we relying too much on Active Directory? What can we do? And you had some great questions that came through. We are kind of close on time, but I will just at least hit maybe one or two questions, and I've pinned the rest for you in your Slack channel. Dan asked, do you have a sysmon config you recommend for some of the detections and hypotheses that you are drawing?
So I'll take that first and I'll let you chip in. There are a number of sysmon configs, so Swift on security is the one which everyone goes to. What we did while doing some of this work was we picked up that and we made changes to that to tailor that to the attacks which we were launching to see what triggers. Nothing off the shelf works, as we all know, right? So we need to get that, make changes, and tailor that to our own environment, depending on what normal is in our environment.
You mean there is no silver bullet?
I wish there was.
Right. Then we wouldn't be here today, right? So thank you so much for taking the time to present with us today. And thanks for, helping us with that technical issue with some people not being able to and switching your presentation there. Appreciate that. And once again, the questions are there for you in your Slack channel.